Welcome to Brain Vision.
For part A, the potential energy at the turning point is equal to the total kinetic energy as it passes through equilibrium. So we can say 1/2 times k times the amplitude squared would be equal to 1/2 essentially the translational kinetic energy plus the rotational kinetic energy omega squared. This would be equal to 1/2 times m sub v sub m squared plus 1/2 times 1/2 mr squared multiplied by v sub c m over r quantity squared. This would be equal to essentially 3/4 m times v sub m squared. And we have now that m times v sub c m squared would be equal to 2 times the spring constant times the amplitude squared divided by 3, and this is equaling to 0.125 joules. Therefore, the translational kinetic energy would be equal to kx sub m squared divided by 3, and this is equaling 0.0625 joules. This would be our answer for part A. For part B, the rotational kinetic energy, 1/4 times m sub v sub c m squared. This would be equal to the spring constant times the amplitude squared divided by 6. This is equal to 0.03125 joules. And so this would be our answer for the rotational kinetic energy as it passes through equilibrium. For part C now, we need to denote v sub cm instead of denoting the maximum speed of the center of mass as it passes through equilibrium. We can use this to denote the speed at any instant. So the change in the energy with respect to time would be equal to the derivative with respect to time of 3/4 m times v sub c m squared plus 1/2 times kx squared. And we find that this is equaling 3/2 m v sub c m a times sub c m plus kx v sub c m. We're going to set this equal to 0. So the acceleration would then be equal to -2k divided by 3m times x. We are going to compare this to equation 15.8. And so we find that then the omega, the angular frequency, is equaling the square root of 2k over 3m. And this is equaling 2 pi over t. We know this to be true, so therefore solving for the period t, this would be equal to 2 pi multiplied by the square root of 3m divided by 2k. This would be us essentially proving the equation for t. That is the end of the solution. Thank you for watching.